Guys, welcome to the second video analysis prac. In this particular prac, you guys are getting your first exposure to the Canovia video analysis software package. What we'll be doing in this particular prac is to assess and analyze the throwing ability of experienced versus novice water polo players. So once you've loaded and started up the Canovia interface, you'll need to find out where you saved your video. It's just a matter of going through the relevant folders where your videos are located, and in this one I'm going to select this particular video for my analysis. It then loads it up, and from here our analysis can start. What I'll do is just show you guys how to get the information that you need and how to record the information that you need. In the second video, what I'll do there is to show you guys how to use that information to run some analytics. At the end of the day, we're trying to see, are there any significant differences between inexperienced versus experienced water polo players in terms of their throwing speed, the angle of release, the maximum amount of shoulder external rotation, and then also the maximum height of the head above the water. So we'll see if we can get all that information out. Once your video is loaded, one of the first things that you'll want to do is just to crop the video, and I must just apologize in advance. I think the way most of these software work is that when I make a video of this stuff, as in other words this tutorial video that I'm making, it might seem very staggered, but that's just the nature of the lag between me making this video and what you'll see on screen. So I just apologize in case that does happen. You'll see there's a scroll bar here at the bottom. I'm going to scroll it forward, and you can see here that the video starts to play. I'm going to scroll it forward to the instant where the ball basically is about to leave the screen. So that's where I want my analysis to end. And in order to crop it there, I'm just going to go over here and I'm going to set this as my last working frame. So you'll see everything here was deleted, and I'm just going to be running between the beginning and that part where the ball is about to leave. Right, the second part that I want to do is, because this video was recorded at 500 frames per second, I just have to give the software package that information. So I'll just scroll up here. I go to video, configure video timing, and you'll see that according to it, it was captured at 50 frames per second, which is a lot slower. So I'm just going to make that 500 and 500, and then just click apply. Okay, the next thing that I'll have to do is give it some numbers to work with. The computer works with pixels, but that's useless information for me. So what we'll do is, since it's really important to calibrate a distance within the plane of motion, we'll use the ball. Since the ball is exactly where the athlete is, I'll use that as my calibration distance. So in other words, if I know what the diameter of the ball is, the computer will, and I'll give it the known dimensions of that in terms of meters, and then the computer will use that to convert any pixels on screen into a relevant meter dimension. So how do I do that? I just go down here, I use this line tool. I can hold control and the scroll button on the mouse just to zoom in a little bit. I'm going to go from one edge of the ball to the other edge and try and make it as accurate as possible. Alright, then I right click on it and I say calibrate. So the diameter of a female water polo ball is 21.33 centimeters. So I'm going to convert that to meters. I'm just going to select the meter option over here. I'm going to say 0.213. I'm going to give it apply. So you'll see here now it's given that length a calibration distance of 0.21 meters. Alright, that's cool. So then I can hit the escape button. I can also hide this. I right click on the line and I'm going to delete it for now. I'm going to make that a little bit bigger. Alright, then the next thing I'm going to do is I'm going to right click on an area of high contrast. So this blue dark area contrasts nicely between the red and the yellow, so I'm going to right click on that and I'm going to click track path. Okay, it's going to come up with a box that's going to automatically track where this ball is at any instant in time. I'm just going to change the color, so I'm going to right click it and click configuration. Then I'm going to click this color option and I'm going to give it something a little bit lighter that's a little bit easier to see. No, I don't like that color. Alright, let's just go with that. In terms of measurement, I want speed. The marker I want to look like a target, and then I can click apply. Alright, and then all I'm going to do is click the play button, and you should see it should do a fairly accurate job in terms of tracking the ball. It might lose it a little bit here, but we'll see what happens. Alright, and that's not too bad at all. And you'll see here automatically updates the speed component in meters per second, and that's exactly what we're interested in. So for now, I can go through this frame by frame. So you can see there's a scroll bar here at the bottom, or I can click this to just go to the next frame. So I'm going to get it to the point of interest, which is at the instant that the athlete releases the ball. I want to find out what that release velocity was. So that's basically when her fingers are just about to lose contact. If I just go a little bit back, looks, yeah, one back. So at this instant over here, the release speed is 11.8 meters per second. What you guys are going to do is there's an Excel template. Since you're going to be analyzing a total of 9 throws, the first throw is 11.8 and your units are in meters per second. Later on you can always convert it to kilometers per hour, but that's fine. And I'm going to go back to here. The next thing I want to assess and analyze is to find out what the angle of release is. So since this is the instant of release, I'm going to try and get the angle. If you've got the experimental version of Canovia, what you're going to do is click and hold on this angle component, and then I want the angle to the horizontal. Okay, then I'm just going to click somewhere on the screen, and then I can click and drag. In essence, what I want to do is to get the center of her wrists, sorry, the center of a ball, and then you're just going to measure the center of the ball for a few frames as it is being released. Remember, it's going to get pulled down by gravity, and I want to get the center of the ball, not this portion here that was tracked in terms of speed, but in essence the center of the ball. So just for a few frames you'll see that the center of the ball is not quite along that line, so I'm just going to make it a little bit lower, and there, for those few frames over there, the center of the ball is basically tracking along this line over here. So that's going to be my angle of release, which is 10.4 degrees. So I'm going to say 10.4. Alright, then what I'm going to do is I'm going to just delete that. What I want to get to next is the maximum shoulder external rotation. So that has to be taken in a plane where the elbow joint is basically perpendicular to where we formed. So once the elbow joint is around about here, this is the angle of the shoulder joint I want to measure. So again, I'll use that same tool, angle relative to the horizontal. I'm going to click on here. I'm going to put the central axis on the middle of the elbow joint, and then I'm going to drag this and line it up with the center of the wrist at that instant. Okay, so you can see that's 140.5 degrees. I'm going to go back to my template, 140.5 degrees, and then the last thing I need to do is just measure the maximum shoulder height at the instant of release. So let me just go back to where the ball is about to be released, which is over here. So again, I want to find out what's the maximum height of her head above the waterline. I'm going to use this distance tool again, and then I'm going to drag it from the top, the highest part of her head, to where her body is basically just about to leave the water. I'm trying to draw a vertical line, as vertical a line as possible. And you can see there that that's 0.44 meters. I'll go back to here, 0.44. Alright, So this would just be one shot. We're going to do that for a total of 9 shots to get a really good average between the experienced and the inexperienced individuals. So what we'll do is I'll leave this video here for now, and you'll finish that for both the experienced and the inexperienced individuals. And then the next video I will show you guys how to analyze that information to make sense of it and how we can differentiate between different levels of performance. That's it for now.